Just go on YouTube. It's going to be there. I'm sorry about that. Yeah. Oh, the internet also is not working? Amazing. Okay, the internet is working. That's good. Okay, all right. So, do people see the screen on YouTube? Is that okay?
The internet's really low.
No?
I'm sure it's there. We're just all having trouble accessing it.
Oh, okay. That makes sense. There's too many. Okay. So I think so. The first part of the lecture was a PowerPoint anyway, and it's just me talking. There's nothing that interesting on the screen, so I'll just talk a little bit. Actually, I'll write on the board a little bit. So now that you've seen, oh, there's no chalk either. Great. Okay, there. Oh, I see. Okay. I'm sorry. Okay, nothing goes my way today, does it? Okay, and the internet is also not working. So go to the lecture that starts at 2. If you just, on YouTube, just say ESC week. I'm sorry about that. So UofT ESC180 week 2, lecture 1, 2 p.m. Just search for that, it's there. Computer program is a series of instructions to the computer that says put this value here, or maybe put this on the screen there, or something like that, right? So, for example, something like this would be a very simple program that just says print oops to the blackboard. With my luck, that wouldn't work either, but in principle, right? So something like this might be more complicated. This is the chalk I have. So something like this would be more complicated. There really no chalk though? Okay. So something like this would be more complicated. So this is 2 instructions. So one is put oops on the screen, and one is take 42 and put it in the variable a. Right? Now, the result of this is still the same. It's just putting oops on the screen because this just happens internally in the computer. It doesn't affect anything. So you could imagine doing something like a is 42 plus 1 and then print a. Wait, so did the tech support guy just disappear?
Your call is being connected.
Apparently. So okay.
We sent someone over.
Okay, thank you. Yeah.
Just wait a little bit.
Yeah, you I don't think you mentioned it, but thank you. Okay, all right. So this would be a program that does something. Specifically, it prints oops to the screen. Then internally, it computes 43. It puts 43 inside A, and then it prints A. Right? So A would be 43, so the output would be oops, and then 43. So that's code in Python. Python is what's called a high-level programming language. So that means that you can give it quite complicated instructions. So what's an example of a complicated instruction? Well, this is actually quite complicated, right? Because if you think about making a mechanical device that would do something like that, specifically the way it's done on your computer, that would not be that easy, right? So on your computer, it's not like it's OOPS. It's like OOPS in a particular place on the computer, in a particular font. If you have some kind of accessibility settings turned on, then maybe a screen reader is going to be able to read it and stuff like that, right? So actually, this, while it looks like a simple instruction, is actually an extremely complicated instruction. Look up the font, figure out look up all the fonts, figure out which font the user actually wanted, that's somewhere in the settings, whatever kind of contrast, whatever, then figure out the location on the screen where you wanted to put that font, and then pixel by pixel display the actual oops. Right? If you kind of played around with some settings on a laptop or something, you'll see that that's not even the end of it, because on some operating systems, sometimes you can turn on and off options that modify what the pixels are depending on exactly where and how you display things. Because, for example, you want them to look prettier, so depending on the size, it's not exactly going to be like a pixel to pixel. There's software that takes out the blue light in the evening that supposedly helps you sleep better if you don't have blue light coming from the screen, stuff like that, right? So the point is, it's a complicated process. So that's why we say, like, print oops seems simple, but that's actually a high-level programming language. So every computer that we have in this room and that's trying to connect to the Wi-Fi here is actually built from the low level up to the high level. So what that means is that while those kinds of programs are running on the computer, at base what's happening is there are a bunch of ones and zeros somewhere inside the computer, and those ones and zeros are running low-level programs where the ones and zeros result in like one pixel being turned on or turned off, right? Ones and zeros, I think everyone has heard. So how does that work in practice? Well, you have a chip, and at a particular location on a chip, you have either low voltage or high voltage. So for that particular location, it's either 1 or 0, depending on whether there's low voltage or high voltage in there exactly, right? So at the lowest level, what's happening is instructions that are kind of the same way. They still say do something, but they say do something much simpler. So an instruction might be, so you have your bits, so that's like somewhere in memory like this, and an instruction might be take 8 bits here, meaning transform the low and high voltage patterns here to something else. And it might be that one of the bits somewhere on the chip is related to the pixel being off or on the screen, and using multiple instructions like that, eventually you get to be able to execute something like print oops. So that's kind of at the high level. That's like a 3-minute introduction. Of course, kind of in computing courses in EngSci, we'll spend like the first 2 years slowly and methodically explaining exactly how it works to you, so that by the end of second semester, second year, you'll hopefully have some idea. And then, like, if you choose to specialize in ECE, maybe eventually you'll even understand it. But that's kind of the basics of it. So most programs those days are not written in that style of let's just modify things bit by bit. That's really complicated. Most programs are written kind of like that, either in Python or in some other language. So Python in particular is kind of designed to be as human-like as possible, right? So you can almost read it as, like, you can always intuitively understand what it means to say, like, compute 42 plus 1 and then put it into A, right? So what we saw, so here I really would need to switch to, so how many people can see the YouTube now? Okay, look at the YouTube. So we were using Paizo, right? And basically what's going on is you can type Python instructions here into Paizo like so. And what this is a program named, in this case, Python 3.7.13, that's running on my computer and that's displaying inside of Paizo. Paizo itself is a program into which you can enter Python code. So something like this. And then what you can do is you can run it, and the way it runs is Paizo, the software Paizo, which is software like Word software, is sending this code, print oops, to Python, and then Python executes it. So what it means to execute print oops is to just print oops to the screen. So Python is both software, so what you see there, Python 3.7.13, that's software that's running on my computer, and it's a programming language in which you can write instructions that you send to the software Python. Python is running inside of Paizo. So it sounds complicated, but at the same time, if I don't say it, then people are saying, well, like, you didn't tell us what anything is. So now I told you. The Python software is referred to as the Python interpreter. So that's because it interprets the instructions that you give it and then executes them. So Paizo, so we'll use it for a start, then we'll stop. Basically, it's just software that allows you to write Python instructions, Python programs, and then give them to the Python interpreter, to the Python software in order to run. Why are we using Paizo? Well, we'll see in a minute. Basically, it allows you to very efficiently look through the program and see exactly how it runs. I would say better than other development environments. So Paizo is a type of software that's called an IDE, an integrated development environment. So that's just software that allows you to write code in it and then run the code, like, for example, Paizo. Paizo, interestingly, is itself written in Python, and we can take a look. So this is a screenshot from another computer, but if you go to help, you have actually the code that constitutes Paizo. So I can just go there. Maybe. What was it again? Oops. Imagine bin. Not this. Local. Is that hidden? Okay. So local lib Python 3.10. And you can follow along as well to just open the thing on your computer. It's not going to be super interesting. So this would be, for example, part of the Python code that actually runs Paizo, and you can in fact run it if everything is set up correctly to get another copy of Paizo. So I can try to do it. I haven't actually tried it today, so I don't know if it's going to work, but nope. You could though set up so that it actually works, and if you want to modify Paizo, you can. So you just go to that code, you change the code, and Paizo starts behaving differently. You can do it. So, okay. So that's kind of the high-level introduction. I also want to do, like, quickly how to succeed in ESC180. Well, be on time, bring chalk, stuff like that. But other than that, so ESC180 is really about, it's on the slide on YouTube. So ESC180 really is about solving problems using programming. It's not so much about learning the rules of programming. And I would say kind of people are maybe sometimes misled about that, but this is something that you should be quite used to from, for example, high school math, right? So high school math, it's not about learning the rules of math. Like, the rules of math are pretty simple. You learn them mostly in elementary and middle school. Like, you learn how addition works, you learn how multiplication works, and so on. Most of the time that you spend in math is not learning the rules, it's learning how to combine the rules and apply the rules in order to solve some kind of problem. And it's exactly the same here, so you wouldn't have seen examples yet, and you wouldn't have seen substantive examples until maybe a couple weeks from now, once we've got a handle on the rules. But most of the class is really about, here's a problem, let's solve it with programming. It's not about, here's how, like, here are the detailed rules about how this works, here are the detailed rules about how that works. We will have some of that. We'll spend maybe 3-4 weeks on just learning the rules. Most of them are pretty intuitive. Like, for example, one rule as well. Like, you take the right-hand side and you put it in the left-hand side. You probably all know it by now. Not difficult. Some of the rules are kind of tricky. In fact, one of the more complex topics in this class is figuring out the exact rules about how to handle something called lists and nested lists in Python. That's genuinely difficult. Most of the stuff is easy. The hard part is combining everything. And you can't really learn how to combine, how to make things work together, how to combine them in order to solve problems by listening to lecture. I'm useless. By reading a textbook. I'm not trying to write a textbook. If I did, I would also be useless. It's all about actually trying to solve practice problems and kind of getting into the mindset of, okay, like, this is how I get from a problem to a solution. How do you learn it? Well, one answer is practice. Another answer might be a little bit reflective as we try to get to more complicated examples, be a little bit reflective, like, here is a and that applies not just to ESC180, but I think to almost any class. I don't know about Praxis, but almost any class, Praxis too, in here, right? So, like, you see a problem, you see a solution to it that was explained in lecture, or that you maybe attempted in the lab, but maybe didn't completely complete. What you got to think, I think, in part is, okay, like, I couldn't get there initially. Okay, what was I missing that would enable me to solve that problem next time? Hello.
Keep teaching all.
Yeah. And I mean, kind of reading is good. You should come to lecture, but also keep in mind that really it's about practice. So, okay, I tried that. So that's that. So now I want to go in a little bit more detail about conditionals. So what we had last time. So if you remember, we had a particular rule about how conditional works, right? So we say if, then we have a condition. So here I just did kind of condition in angular brackets. The condition in angular brackets is just something that's either true or false. Thank you for spending so much time. Now the students know that it's not completely my fault. I mean, mirror usually is what I know. Yeah. Okay, that's a little bit different. Oh. Okay, it was kind of my fault. Okay, thank you. So, okay, all right. Sorry, so, okay, oh, yeah, you're taking evidence, okay. So how do you do that?
It's this. I don't know why
I tried that.
Stuck
Yeah,
on something else.
I see.
This is the one, then.
Oh, I see. I did try that. Yeah, okay, thank you. Yeah, it's okay. I'm broadcasting to YouTube, so they were fine,
cool.
Probably. Okay, all right. So that's, can everyone see in the back? I guess you could keep looking at YouTube. Oh, the microphone is not working? One. 1? Yeah, cool. Thank you. Thanks very much. So, all right, so that's the rules for how you do it. We hadn't last time had more than one line inside block 1, but in principle, you could have more than one, right? So, for example, you could have something like if 5 is greater than 4, print okay. What else do we like? So if I run this, what would it do? Well, this whole thing is block 1. So if this condition is true, then block 1 is going to run. So that's going to print hello EngSci and I love praxis. It's not going to print I love calc. So this whole thing is kind of one big chunk of code. After that chunk of code, you can say something else. What else do we have? Okay. So something like this. So if I run this, what's going to happen? Well, this block 1 is going to be executed. This is not, because it's either this one or this one. And then I love physics is outside of the if-else. So that means that it's definitely going to run whether 5 is greater than 4 or not. So that's what we get. So what happened is this ran and then this ran because this was both inside the if. Then this didn't run because that's inside the else. And then this is not inside the else. So so this is called indenting. So in Paizo I do it by pressing the tab button. So on the upper left corner. So if I indent it, then it's different because now both I love calc and I love physics are in the same block and they're inside the else block. So if I run this now, it's going to be hello EngSci and I love praxis, but no love for calc or physics. Make sense? Yeah.
How do you only run the part that you highlight?
Alt-Enter is the way I run the highlighted part. So if you don't remember the keyboard shortcuts, they're all here. So here, this is execute selection, so that's kind of the highlighted part. So in fact, I couldn't run the entire thing now because there's stuff here that's not really Python code. I can comment it out, so making something a comment by putting a pound sign in front of it is referred to as commenting it out. So now Python is going to ignore it when I run it. So now I can run the entire thing if I wanted to. So in fact, let's do that. So I'll select all. So select all, by the way, is Control A, and I can press Alt-Enter. Invalid syntax. Yeah, so this is not actually Python either, right? So this is just kind of a demonstration. So to comment everything out, you can do Control R, like this. So now all of that has become a comment. So I'll select all just for the sake of it and run it like this. And here it has run. So if you want to run the entire file, so right now it's tmp1, what you can do is Control E or Command D on the Mac. So that's over here. So that's execute file. So that's the usual way. If you write a large program, you want to run it, you probably want to say Control or Command D on the Mac. You can, but you don't have to. Just select all and then say Alt-Enter. That's another possibility. So, okay. So let me just show you another example. So this is like another somewhat useless program. So here I have like my exam grade. So this is like after you get to the midterms, you'll see what I'm talking about. And let's say that there is adjustments. Okay, this is like too mean. 80. So we never adjust down. It's a joke. In fact, I'll change it to a plus. Although, of course, now that I've changed it to a plus, the EC adjustment should be higher. So here I just have exam grade, that's 80, EngSci adjustment is 20, EC adjustment is 21, completely made up. And then I have my program where I say make exam grade be whatever it used to be plus EngSci adjustment if the exam grade is greater than 70 or equal, and otherwise make it exam grade plus EC adjustment. So if the exam grade is 80, that means that we are adjusting using the EngSci adjustment, so it's going to be 100. On the other hand, if the exam grade is 60, so now 60 is not greater or equal than 70, so that means that this part will run, and that would be 60 plus 21, so 81. Make sense? So I want to show you something that's really important, and a lot of people, at least in the beginning, don't do it because maybe they don't see the value. We'll make you do it several times in the lab because it's actually important and helpful later on when you write larger programs, and that's tracing. So what I'll do now is I'll put what's called a breakpoint over here. So what I'm doing is I'm clicking in the gray rectangle here. So this says run the code, but step by step, and start running step by step at the breakpoint. So if I press Control E now, so nothing printed yet. So what's going on is Paizo is now on line 7, and it's deciding is 5 greater than 4. If it is, then we'll go to line 8. If it's not, then we'll go to line 11. Now it happens to be true, so if I press next, so next is this button here, so the curvy one. So now we're on line 8, so we're about to print hello EngSci. So I press on this button again, and now you see hello EngSci, and now I press on this button again, and we have I love Praxis, and notice what happened. So the else doesn't get executed, it's either one or the other. So we skipped over line 11 and we went right to line 18 because line 11 is not supposed to be executed because 5 is greater than 4. So now it's about to become the case that exam grade is equal to 60. And by the way, it was already 60 because I already ran the program before, but you can check here in the workspace. If you don't have the workspace, you just do tools and then select the workspace. That'll appear. So you can check over here that exam grade is 60, or you can just type in exam grade over here, and that's also 60. You can say, okay, like if hypothetically I were to add 20 to it, what would it be? And it would say 80. So note that saying exam grade plus 20 does not change exam grade. It just says what's exam grade plus 20. So if you check what exam grade is, it's still 60. And that's the only way it could be, right? Because if you can say 5 plus 12 is 17, well, obviously that didn't change what 5 was. So in the same way, exam grade plus 20 is not going to change what exam grade is. So all right, so now EngSci adjustment is about to become 20. And then it already was because I already ran all of this stuff. And then now we set the C adjustment to 21. So now we are asking, is exam grade greater or equal than 70? Who says we're going to go to line 22 now? You're correct. We are going to go to line 24 because exam grade is not greater or equal than 70. So now that's about to be executed, so we can keep track. So exam grade right now is 60, and then when I press next the next time, exam grade has become 81. And now it's going to get printed. So Paizo, it's honestly the most convenient thing, but when you're at the last line, it's a little bit inconvenient. So I recommend that you press this button when you are on the last line. Otherwise, it could be trouble depending on your system. So in general, those buttons, we'll go over it again when it becomes kind of more relevant. So for now, what's relevant is this button, which is just debug next. And then this button, which just means start running normally without going line by line. So if I press this button, it'll just run to the end. Then I'll run it again. And then this button, which to be honest does not always work the way it should, is stop debugging, so that'll just stop whatever happens and nothing happens anymore. Doesn't work that reliably, to be honest, but oh well. All right, so that's like that. So now let's do something that's a little bit more complicated. Not that. Really? Wait, I fixed that. So you could have something that's a little bit more complicated than just an if-else. This is called elif, or people just say elif or elsif. So, and it's this kind of structure. So it's like if condition 1, and then you check condition 2, condition 3, and so on, and then at the end, maybe you have an else. So the way it works in Python is you first check condition 1, and if condition 1 holds, you just do block 1 and you're done. You go to the next thing over here. And then if condition 1 is not true, then you check condition 2, and if condition 2 is true, then you execute block 2, and then you just go to the end, you don't check anything else, and so on. And then at the end, if there is an else, you don't have to have an else, in the same way that we didn't have to have an elif. You don't have to have 2 elifs, you could have 1 or 3 or whatever, and you don't have to have an else. But if there is an else, then if none of the conditions held, then you'll do the else. So here's an example. So if you say, for example, exam grade is 99, and then the conditional is if it's equal to 98, then both of those are going to run because the entire block is going to run. If it's greater than 98, then it's going to print I am happy. And if neither of those is true, so if the exam grade is neither 98 nor greater than 98, then you'll print a sad face. And then here you have, at least I'm not in artsy. In addition to being slightly funny, why is it there? Well, to make a point, right? So this is going to print regardless of your grade, which for a while is going to be true. Like, doesn't matter what your grade is, you're still not in artsy, well, until the winter. It's honestly fine. We are like as nice as arts and science, like in terms of grading as well. So here we already saw this kind of example, but just to show it to you again. So I run this. Oh, I didn't set the exam grade. It was whatever it was before. So let's say the exam grade is 99. What's going to happen? Well, we skip this, and then we do this. So we print I am happy, and then we go to the next line, which happens to be print at least I'm not an artsy, right? And this line is going to get executed regardless because it's going to be either this one or this one or this one, and then definitely this one because that's not part of the if-else block. Again, If you don't want to kind of display sour grapes unnecessarily, well, I guess it's the opposite of sour grapes, sweet grapes. So if you just want to print it after the set face, if the set face is appropriate, you do this. So now this is part of the else block because it's indented, so there's white space in front of it. So if we run it like this, it'll just print I am happy. In order to print this, it would have to be the case that it's neither the case that exam grade is 98 or that exam grade is greater than 98. So if it's like a 97 or something, then what's going to happen is you'll print, at least I'm not an artsy. So we can, again, trace it just for the sake of the example. So what I'll do, so here you see that actually all of those are defined. So what I'll do is I'll restart so that I don't have anything in my workspace other than kind of the built-in stuff. So this is just stuff that, not Paizo exactly, but IPython introduces to keep track of like the previous command, stuff like that. So I run this. So now I'm on line 1, so I'm about to say exam grade is equal to 97. I'll do next. And now this appeared. So exam grade is now 97. So here, is it equal to 98? By the way, one useful technique is to be able to highlight this and evaluate it. So is this true? No, it's false. The way I figured it out is, so highlight, Alt Enter, that just runs it on the right. So now I know that I'll skip it and I'll go, so who says I'll go to line 8? What line am I going to go to now? Yeah. Line 5, exactly. Because I know that it's not 98, but I don't yet know whether it's greater or equal to greater than 98 or not. So I'm skipping this part because it's not equal to 98, and now I'm going to be on line 5. Is it greater than 98? Well, now it's going to try and see that no, it's not. We can tell ahead of time by just highlighting and doing Alt Enter to see that this is false. And now I'll say next, so it'll of course skip. And here, don't need to go to line 7 because else is definitely going to get executed if you're at that point. And now we're going to print set face, and at least I'm not an artsy. Okay, that's it. So you'll practice this on Wednesday and Thursday in the lab. Please try to install Paizo before that. If not, the TAs will help you, but please try to do it before the lab. All right, see ya, thanks.